Okay, so let's talk about graphing cosecant and secant. Right? So suppose we wanted to graph y equals, how about 3 times cosecant of negative pi over 2 times x minus pi plus 2. Okay, so if we want to plot this, the very first step is plot instead the reciprocal function. So y equals 3 times sine of negative pi over 2 x minus pi plus 2. Right, so I'm going to plot this instead, okay? Yeah, and like this will be the majority of the work, just plotting this, okay? So what do we do to plot this one? Well, there's a four-step process to that as well. All right, I'll call this step A, since I'm already using 1 over there. Okay, so now to do this, first thing we need to do is find out what the period is, right? We usually use T for that symbol, and that's always equal to 2 pi divided by B. Now, the problem with this is that we always assume that our b is positive when we do that, but clearly we can see our b is a negative number here. Okay, so what can we do? Well, we have I'll write this as an aside right here. We have the even and odd properties. Sine is an odd function, which means that sine of negative theta is really just the same thing as negative sine of theta. So we can rewrite this as negative 3 times sine of pi over 2 x plus pi plus 2, where I factored a negative out of every single term inside the parentheses here. And then using the fact that it was odd, I was able to factor that negative sign out front. Okay. So then now we have an a, which is negative 3, a b, which is pi over 2, and might as well write it down. A equals negative 3, b equals positive pi over 2, c equals negative pi. Don't forget, if there's a plus sign on the inside, that means your c is negative, right? D is equal to positive 2. Okay. So then our period is 2 pi over b, so that's 2 pi divided by pi over 2, right? And so we're going to simplify that. That's the same thing as 2 pi times 2 divided by pi, right? Multiply by the reciprocal, right? Our pi's cancel off. So our period is 4, okay? And then the next thing that we need to do in part A is find the horizontal shift, which is just equal to c divided by b, okay? So my c here is, remember, negative pi. Okay, and we're dividing that by b, which is pi over 2. Okay, so that's negative pi times 2 over pi. My pi's cancel off. So I'm going to get a horizontal shift of negative 2, 2 units to the left. All right. Now, part B over here is to find the x values of our key points, right? And our x1 is always just equal to whatever our horizontal shift is. That's just negative 2. Our x2 is always going to be x1 plus a quarter of the period. Right? Just take 1/4 of the period, right? And so maybe in part A, it might be a good idea, or again, right, this as an aside right here, okay, to go ahead and compute what a quarter of t is. 1/4 of t would be 1/4 of 4, which is just 1. So our x2 is just whatever we had for x1 plus 1. So that's going to be negative 1. Our x3 will just be x2 plus a quarter of t, so just add 1 again. Our x4 would be x3 plus a quarter of t, so just add 1 again. And our x5 will just be x4 plus a quarter of t, so just add 1 again. So now we have negative 2, negative 1, 0, 1, and 2 are our x values of our key points. Okay. Part C is to do the y values, right? Remember, we're plotting sine over here. So we're going to do our y1, y2, y3, y4, and y5. And for just plain sine of x, the y values would be 0, 1, 0, negative 1, and 0. But now, right, we have to remember that we're not just doing sine of x, we're doing sine of stuff, and we're multiplying that by 3, and then, sorry, we're multiplying that by negative 3, and then adding 2 to it. So I need to take all of these and multiply them by negative 3 and add 2 to them. Okay, so always multiply them by a and add d to them. Okay, so now simplifying that, we get that this is 2, which means that this is 2 and this is 2 as well. This is negative 3 plus 2, which is negative 1. This is positive 3 plus 2, which is 5. Okay, so now I have my x values and my y values for my key points. So then I'm going to go ahead and part D here is just graph that sine function. Okay, keep in mind, I really want to graph this cosecant function, but I'm going to graph the sine function first. Okay, so looking at my x values, I see that they're pretty symmetric from -2 to +2, so that's good. Okay, my y values, those ones go from -1 up to +5, right? So I'm going to need my y values, right, to be more in the positive direction than the negative direction. Okay, I'll write my, oops, that's not a very good x-axis. Doesn't look very horizontal to me. Doing my best here. Yeah, how about that? Okay, that's okay. So now my x values, again, they go from -2 up to +2. Try to make it as symmetric as possible. So -1 right there, -2 right there, +1, +2. You can even go a little bit further if you want to, right? All right. Now my y values, they go from -1 up to +5. So 1, 2, 3, 4, and 5. Okay. Give myself a little bit more room here. Okay. 6, 7. Sure. Maybe over here too, I'll go -2, -3. Okay. So now the first thing I'm going to do when I'm graphing my sine wave is I'm going to put in my axis of symmetry, which is just wherever D is. So D is 2, right? And so I'm going to go ahead and put in my axis of symmetry there at 2. So here's y equals 2. Okay. All right. So now that I've done that, now I'm going to go ahead and plot my key points, right? Scroll up just slightly here. My x1 is -2, my y1 is 2. So here at -2, I get a y value of 2. Okay. And then we have -1, -1, right? So we're going to go down to here. Okay. And then we're going to go 0 to 2, right? Okay. And then we're going to go 1, 5. See, 1, 2, 3, 4, 5's over here. Make sure to count. Yeah. And then 2, 2. So my graph is an upside down sine wave, which we knew because our A was negative, right? It looks a little bit like this. Okay. Really, that peak's supposed to be right there. Okay. Now, right, I'm just going to extend the graph out just a little bit. We don't have to do this. This is purely optional. But I just want this to, sort of show a little bit more of the graph is all. So it's going to go down to there and back up to there. There we go. Now, when we're doing cosecant, which remember we wanted to do cosecant, right? So when we're doing cosecant, now this is on to step 2. Anywhere where sine is equal to 0 is going to be a vertical asymptote for cosecant, right? So I'm going to do this in green. So I'm going to have a vertical asymptote here for cosecant, right? I'm going to have a vertical asymptote here for cosecant. And so the reason that we have a vertical asymptote at these places is because that is exactly where we'll be dividing by 0, because cosecant is the reciprocal function. Okay. Oops, that didn't look too good there. These don't have to look perfect, but I try to make them as good as I can when I'm trying to do these videos anyway. Okay, now we're almost done. Now we've put in those vertical asymptotes. The rest of this goes like this. Um, Anywhere where there's a maximum or a minimum y value, cosecant also has those values. Okay, so those will definitely be on the graph of cosecant. Okay, good. And then now, for all these maximum y values, cosecant looks like a U shaped just like that. For all these minimum y values, cosecant looks like an upside down U, just like that. Okay, so just go ahead and draw all those in. And there you go. There's your graph of cosecant. Not too bad. Now, fortunately, it's pretty much the same steps to do secant. So let's go ahead and do secant. Okay, the exact same process. Okay, so I'm going to use black, let's say here. All right, so now let's try to draw the graph of y equals 3 times secant of -pi/2x minus pi plus 2. Okay. Now, again, I have this b that's negative, but I always have my formulas with b being positive. But let's note here that cosine and secant are actually even functions. So secant of negative theta right? Because it's an even function, secant of negative theta will just be equal to secant of theta. So if I factor out this negative from the inside part right here, I get that this is really the same thing as y equals 3 secant of positive pi over 2x plus pi plus 2. Just factoring the negative out and then saying, now we can ignore that negative sign, right? Fair enough. Even function. Okay, so that's different than the odd function. The odd function, I factor the negative all the way out and it became a negative 3 out front. Now I still have a positive 3 for secant, though. Okay, so now our step one is to instead graph y equals 3 cosine of pi over 2x plus pi plus 2. Okay, so we're going to do a lot of the same work here, right? But that's okay. We'll just do it again, right? Let's talk about the period, right? Which is equal to t, right? Which is always equal to 2 pi divided by b when we're talking about sine or cosine, right? So let's go ahead and say that a is 3, b is pi over 2, c is equal to pi, and d is equal to 2. Okay, so we do 2 pi over b, so that's 2 pi divided by pi over 2, right? So that's the same thing as 2 pi times 2 over pi. Pi's cancel off, and we're just left with 4. Okay, horizontal shift, that's always c divided by b. So we're just going to plug in our c, plug in our b. So pi divided by pi over 2, right? So we're going to get that this is pi times 2 over pi. My pi's cancel off, and I just get 2. Right, so exactly the same as it was in for the cosecant graph, right? Okay. Now, oh, sorry, that's part A of graphing cosine. Now, part B of graphing cosine is now we got to do the x values, right? And it is the same x values as I had before. Okay, it's just the horizontal shift, right? Which in this case, right, our horizontal shift is, oh, I made a fatal error here, right? Since I have a plus sign on the inside, my c should be negative, right? So this is actually going to be a negative pi. My mistake there, everybody. So then when I go to do my horizontal shift, I should get this as negative pi here, negative 2 here. My mistake. We need to go back and correct that. Okay. So this comes from the fact that when we do the general equation, we have y is equal to a times cosine of bx minus c plus d. So in order for us to use this format here, right, we would need to convert this positive sign to a minus a negative sign, right? So then that's why we have a c as negative pi. Now, back on to part B over here. Our first key point was always at the horizontal shift, whatever it is, okay? Our x2 will just be x1 plus a quarter of the period. So again, we're just adding a quarter of 4. So we're adding 1 each time. So our x2 is going to be negative 1. Our x3 is going to be 0. Our x4 is going to be 1. Our x5 is going to be 2. Now we're on to our y values, okay? Which look a little bit different than the y values for sine. For sine, it was 0, 1, 0, negative 1, 0. But for cosine, it starts at its maximum value, then goes down to the axis of symmetry, goes down to its minimum, goes back up to its axis of symmetry, and then it goes on to its maximum value. Okay. Now we still do the same thing here. All of these y values get multiplied by a, which is now positive 3, and then d gets added to them, so plus 2. So we're going to get 5, 2, negative 1, 2, 5. Okay. So let's go ahead and plot this then. Okay. So this is going to be part, oh, sorry, that was part C right there. And then now part D is to plot this thing, right? I'm going to have very much the same axes here. So here and here, give myself some space here. Okay, maybe have this go a little bit further down. So this is a negative 1, negative 2, negative 3, let's say. Positive 1, positive 2, positive 3, positive 4, positive 5, positive 6, positive 7. 1, 2, 3, 4. 1, 2, 3, and 4. Okay. And then my axis of symmetry. Let's go ahead and plot that first, which is at D, wherever D is. So in this case, that's 2. So there's y equals 2, my axis of symmetry. Now I'll plot my key points. I get negative 2, 5. So 1, 2, 3, 4, 5. Right? So negative 2, 5 is up here. Okay. I get negative 1, 2. I get 0, -1, right? I get 1, 2, and I get 2, 5. Okay, so it looks a little bit like this. Remember the curvature, so it curves downwards here on this interval, curves upward between these two key points, curves upwards between these two key points, and then curves downwards between these two key points, right? Okay, and we could extend this down, right? Draw a little bit more of the graph, right? We'll see that this goes kind of like this then. Okay, maybe a little bit more, just to get some more detail on this graph, basically. Yeah, draw 2 full periods or something like that. Okay, and then now we want to draw the graph of of secant instead, right? So this is now part 2. Oops. There we go. This is now part 2, where now I'm going to put in the graph of cosecant, sorry, of secant. And since secant is the reciprocal of cosine, wherever cosine touches this axis of symmetry, we're going to have a vertical asymptote for secant. Okay, so just wherever it touches the axis of symmetry, go ahead and put in some vertical asymptotes. Okay. Okay, and one more here. Oops. That's a little bit off to the side there, but whatever. Okay, it's supposed to be right here, x equals 3. Now, right, anywhere where there's a maximum or a minimum y value, right, that shares, secant is going to share that same y value. If it's a maximum y value, then it's shaped like a U, like these two right here. If it's a minimum y value, then it's shaped like an upside down U. Okay. Okay, and it kind of goes off the graph here, right? Okay, but of course there's another vertical asymptote right over here, right? Another vertical asymptote right over here. Okay, and that is plenty of detail for that. So there's your graph of secant in green right there.